So we're going to kick off with the kinetic molecular theory to start our gas unit. And this unit has a bunch of different theories in it, or laws, that we need to understand. This one sort of sets the tone for the rest of those that we need to cover. So there's 4 points to this theory. The first one is simply that gases are compressible. And the reason that they're compressible is because the particles for those gases are just really far apart. If you remember from the bonding unit, when we talked about molecular compounds, when they get really close together, they form intermolecular forces. Gases don't have those. There's no attraction between this gas molecule and this gas molecule because they're too far apart for those attractions to occur. And so because of that, gases exhibit a few strange things that solids and liquids just can't do. And one of them is that they're compressible. And so because gases are compressible, we can measure this compressibility, and we measure it through a unit called pressure, or through a concept called pressure. And there's a bunch of different units that we use to measure pressure, and we'll review those in a later lesson. The next point is that volume and pressure are inversely proportional. So if you think about a balloon, a helium balloon, for example, when you let it go up into the atmosphere, as it gets higher and higher and higher up into the atmosphere, that balloon is going to start to grow and grow and grow and get bigger and bigger and bigger. And the reason why is because most of the atmosphere now is underneath of the balloon, not on top of it. And so because there's less atmosphere sitting on top of the balloon, there's less pressure holding that gas inside of the balloon from getting larger or expanding out. And so because there's less pressure acting on the walls of the balloon, the pressure inside of the balloon is in relation to the pressure outside the balloon getting larger, and so then the balloon starts to grow to the point where that balloon gets so high and the balloon gets so big that the balloon bursts and then it falls back down to the ground. And this is what weather balloons will do. So volume and pressure are inversely proportional. What this means is that as the volume increases, the pressure will decrease. You could also say it the other way, that as volume decreases, the pressure will increase. And so it's just as one goes up, the other goes down. That's what inversely proportional means. This is what's referred to as Boyles Law, and these are under conditions of constant temperature. The last point is that volume and temperature are directly proportional. So again, all that means is just that as volume increases, the temperature of a gas will also increase. If the volume decreases of a gas, then that means that the temperature of that gas is decreasing. So an example of this is if you were to take a balloon and put it into a really, really cold environment, that gas and those molecules of that gas would start to move around a lot less. Because they would move around a lot less, their volume would start to shrink down to a smaller size. And so the temperature affects the volume affects the temperature, and so on. This is called Boyles Law. And so what this means is that that's just what this description is Boyles Law. And this is under constant pressure. So this is kind of the base information that you need moving forward. That's it for this one. We'll see you in the next video.